Oh, hey, what's happening there, YouTube? It's Brian House here for Housework, and today we are going to build an annealing chamber for the inside of my Devil's Forge. Now, I don't even really know if this is a thing or not, but I think it's also called a muffle tube or something along those lines. I got inspired after I was watching James over at Redbeard Ops. He uses a piece of tube steel, he throws it into his forge, and then he basically uses that to diffuse the heat on the inside of the forge. That way you get a nice even heat every time you put a blade in there, and according to him, it greatly increased his ability to regulate the temperature across the entire surface of the blade, and his heat treats came out better, which is something I'm very much interested in. Now, I would like to be able to do that on a scale that is not just a single blade. I like to be able to do it using in my head, I started dreaming this thing up, right? That it would be like a shelving system on the inside of my forge where I would be able to slide blades into the shelves and then allow the forge to warm up evenly. All the blades and everything on the inside would reach the same temperature. I could close the doors of the forge and then let that cool overnight, and what that would do is it would anneal the steel. And a lot of you may be asking yourself, well, Brian, when you do stock removal knife making, isn't the steel already annealed when you get it? And yes, it is, but I actually use my plasma table to cut out the profiles for the blades, and around the outside edge, I get the heat affected zone, the HAZ, or HAZ, I guess is what it's called, where my plasma cutter heats that steel up so rapidly because there's water in the table. It essentially quenches that steel and then hardens the edges. And of course, that may not bother some people, but in my head, I would rather work with a piece of steel that's, the hardness is equal all the way around. That way, I have cracked a couple of blades, and I'm trying to avoid that. So my process is that I, cut the blade blank out on my plasma table, and then immediately after that I throw those blanks into my forge and I anneal them. But I want to be able to make sure that I'm getting nice even heat across every single one of those blades, and I want to be able to have some thermal mass inside of the forge. So I typically just throw a bunch of junk pieces of cut steel in there to kind of give it something else to the heat to hold on to overnight. But in this case, the shelving system would actually be that thermal mass, right? So this is kind of like two birds with one stone. And then on the converse, once I'm done with the blades and I'm ready to actually heat treat them and quench them, I can do the exact same thing where I can set these knives into there, maybe 5, 6 at a time and heat them up nice and evenly. And yes, I know it'll take a little bit more time, but I think it will give me a much better overall heat treatment from a forge anyhow. I'm going to make this today out of mild steel, and I know mild steel probably won't last that long in my forge, and if this concept works and it's something that I really like, I'll most likely move over to, say, stainless or something at that point. Or it might be cheap enough to where I make a few of them, and as they deteriorate over time, I just, make a new one. But when I started thinking about this project, I started thinking like, well, this is kind of a rudimentary concept, right? And to make a video about this doesn't make a whole ton of sense, and something simple. But I really wanted to be able to give you all a primer on how to use Fusion 360. I get that question a lot. I get a lot of people asking me like, hey, how do you do this in Fusion? And what's your prototyping process look like? Do you start here? Where do you start? And this being so simple, I figured, why don't I take you step by step through the process of actually designing this thing in Fusion, exporting it for cutting it out on a CNC Plasma table, and then we'll send the files over to the Plasma CNC table, and then we'll actually cut it out and make it work. That, to me, seems like a great learning experience for all of us. And every single day I work with Fusion, I learn something new, and I'm really impressed with that software. And I know right now there's a lot of controversy swirling around Autodesk's decision to lower the dollar amount for the free licensing and all that. And I've got to say that, as you get further into using Fusion, I think you'll see what I see, and that's the value of that software and what it saves me in time and efficiency, and it allows me to do a lot of things that I wouldn't be able to do otherwise. So I really like Fusion. Now, if you use another piece of CAD software, that's cool. This will apply to all of those things. You know, the same concepts here will apply. And if you've got a piece of software that you like to use, let me know about it. I'm interested. I did buy my yearly license. I got the 40% off deal through Autodesk. Because I felt like, you know what, I just don't want to mess with it, and I'm really happy with Fusion, so I'm going to keep using it. But if you know of something else that's cheaper, let me know down in the comment section. So anyway, enough blathering on about this. Why don't we jump into Fusion 360 and get this project started?
Okay, so we are in Fusion 360. This is just a plain blank canvas, and we are in the design functionality portion of Fusion. There's all these different ways to work with Fusion, and in this case we're going to use design. It's pretty much the way I always use Fusion. And over here you're going to see a couple of different menus and things, and these are something to keep an eye on because you'll see some of this stuff change as we move forward with the design. Whenever you create something in Fusion, you're going to go to the create menu and you're going to start with a sketch. I like this because I migrated away from SketchUp into Fusion, and this made it really easy for me to understand. So we're going to go ahead and hit create sketch, and it's going to ask us on what plane would we like that sketch to be created. And because we're going to use a CNC Plasma cutter, we're going to cut this out of plate steel. We're going to go from the top down, and we're going to use this particular plane as our starting point. So if you can imagine, this is your desktop. You know, you've got your space here, your graph paper, for a lack of a better term, and you're going to start your sketch right here. And with this design, it's very symmetrical, right? So if you can imagine, if you took what I want to design and you cut it into quarters, we would be able to mirror that one quarter in a couple of different ways and create exactly what we want, and it would be perfect at the end. So I'm going to draw this in quarters. We're going to go up to the 2-point rectangle up here in the create menu, and I know that I want it 4.75 inches wide by about 11 inches long. So here we go. We're going to just draw our rectangle, and it's going to ask us, hey, you know, how wide do you want this rectangle? So you can tab between these two things, and half of 4.75 is about 4.237, and then we're going to go 5.5 on the length. So this gives us about a quarter of the size of what we're working with. Over here on the right, you'll see Sketch Palette. You can disable a whole bunch of these features. I personally don't need the points or the dimensions or the constraints. I just disable all of those. Even projected geometries I'm not going to use. This is a very rudimentary design, very simple to understand, so I don't need all that crazy mess on my screen. The next step is I'm going to fillet my corner, and because this is the only corner that's going to exist once I'm done, I'm going to go ahead and hit my fillet tool up here at modify, select the point, and then it's going to ask me, hey, you know, how much fillet do you want? Do you want a big fillet? Do you want a small fillet? And in this case, I think I'm going to go 0.15 on the fillet, and that's just because I am cutting this out on a plasma cutter, and plasma cutters, they can do sharp corners, but because this isn't really part of the design, doesn't really matter, I'm going to go ahead and just round that corner over. Now, because we are going to put the pillars all the way up through this, and the design basically is going to be a series of shelves. So if you can imagine, inside the forge you have probably about 6 pillars all the way through, 3 on each side, and those are going to slide through this piece, and we're going to tack weld those together, and then we're going to probably need some holes or maybe some slots to allow the heat transfer to go through these plates. Now, the way I've conceptualized this in my mind, I don't want holes all the way through this thing. I want it on the outside because I don't want any direct heat hitting the blade or the pieces of steel that are in there. I want this to kind of warm up like an oven and then have lots of thermal mass on the inside, so that all that mass cools, it'll cool slowly inside the forge. So I'm going to use my line tool and just draw a reference line for myself here. And I'm going to use that as kind of a point of reference to where I want my slots and my holes for the pillars. So let's go ahead and hit C for circle. It's a hotkey for circle. And the rod that I'm going to use as my risers in this is going to be 0.25, it's a 1/4 inch rod. So we're going to make the holes 0.3 and give myself a little bit of space. And that will give me a nice hole there. I can hit T, and if I hit T, that's the little scissors or the trim tool, and I can remove segments of lines here. So if you can kind of gather what I'm up to here, you can see inside of this sketch program, you can trim out things, individual slices, and then get rid of that. We don't need that any longer. And then I want to put some slots here for the heat transfer like we talked about, and there's a really fancy slot tool in here. I'm going to do an overall slot, and I think I'm going to do one probably about 1 inch long. So we're going to go ahead and hit 1 on this, and then tab over, and it's going to say how wide do you want that slot? And I probably would be comfortable with probably about 0.3, like the holes. I think that we can just line it all up and make it the same. So now we have a 1 inch slot by 0.3 wide. I'm going to trim the interior out and that one out. And now I don't need this reference line anymore. I'm going to go ahead and trim that one off. But what I want to do is I want to create a cascading version of this all the way across that are of the same size, and they will be spaced out the same. And in order to do that, I kind of need to understand what my widths are. So I'm going to also create another circle down here, and I'm going to draw off of that line there. If Fusion has this great feature, I'm not clicking anything. You can see I'm using this as my reference line, and I'm going over here. And bang, I can create my center hole. I'm going to say 0.3, and I'm going to trim that outside edge because we don't need that any longer. And now I know, okay, I have the space between this hole and this hole. And again, this design is not critical. This is just a heat transfer hole. There's no reason for all this clearance, but I'm trying to give you a sort of a primer as to what Fusion can do. So let's go ahead and go to create, let's see, modify, I believe, and no. We want to go to create and rectangular pattern. That's it. Now, inside of rectangular pattern is going to ask us, what do you want to do? Like, what do you want to extend this to or create a pattern with? And so I went ahead and selected my slot. You saw how I did that. So I'm going to go back real quick, create rectangular pattern, and then select the slot. And it's going to say, okay, how many do you want? Well, I think we can fit 3 in here. And I'm going to just stretch these out. And you can see it's basically replicating the one that I created initially, and it's now stretching them out across the span of the between these two holes. And you can do this by eye. You can do it as much as you want. If you wanted to add a 4th one in there, you can say I want 4, and it'll do 4. But in this case, no, we don't want 4. We want 3, and we're going to go ahead and just kind of eyeball this. I like to draw things with symmetry, which is really simple to do in Fusion. So, all right, so we've got all of that selected. We're going to hit OK, and it is now created 3 slots that are equal distances apart. And let's just go ahead and hit the, let's just look at inspect and measure and find out, like, what's the distance. This is 0.25. Let's do this again. See, did we get it? Yep, 0.25. So we've managed to create some pretty nice symmetry. This is so like I said earlier in the design functionality, that this is just a 1/4 of the entire annealing plate that I'm designing for the inside of the forge. And the Fusion has this great tool called mirror, right? So you come up here, and I need to duplicate this now. So I want to be able to basically mirror it down here. I'm going to click the mirror tool, and then it's going to ask me, what objects do you want to mirror? I want to mirror all of these objects, this line and this line. I don't want to mirror this one because this is going to be the mirrored line. a lot of people that try to use the mirror tool, they will select their entire piece and then it'll basically error out and say you can't do that because you'd need an unselected plane or line to mirror up against. So I'm going to go ahead and select a mirror line. I'm going to tell it I want to use this as my mirror point. And look what it did. It created a mirrored version of it. And now I've got both halves of this annealing plate. We're not quite done yet because obviously we don't need that line. And these two lines are not intersected. So I'm going to go ahead and get rid of these. This is just a nitpick. You don't have to do this. I like my drawings to be nice and clean. So I go ahead and, just create straight through lines so that when I pump it into sheet cam later, you'll kind of understand what I'm doing. You'll see that it's important that your line segments are if you want one cut, you want to have all the line segments kind of intersected. So, all right. So now we have half of the annealing plate already designed. So let's just real quick, let's do an inspection and measure this. I have 8.74. What did I do there? I must have done something incorrect. So let's back this off. My measurements all wrong. Let me just see here. Inspect. I did 4.237 on this initial one. So here, this is a great example of how powerful this software is. So now if I let's just say I messed up, right? I'm going to create a line at the correct dimension, 2.375. And then I'm going to use that as my reference point. I'm going to draw a line here. And we can shave this down. Classic example of me not paying attention. So, all right. So trim this, trim this, trim this. It did look a little funky, right? And now we can use, let's go back, line point, create this here. Now we have a true quarter of the actual plate. So let's go back into mirror. It's going to ask us what we want to mirror. We're going to mirror this. I'm holding shift down to select multiple things inside of this. If you want to select multiple things, you hold down the shift key, or you can drag across. Now it won't select these outer ones because I couldn't select the whole piece. So shift and click, and that'll give you the whole thing. And then mirror this line, boom, hit OK. And then we're going to hit T for trim and remove that line, that line, that line, and that line. And then we're going to create our segments here. I'm sure there's a better way to redraw lines like this, but I have yet to figure it out. So, all right. In fact, let's do this. Let's trim this line and create one big long line on this side. All right. Now we have our proper dimensions. It looks right to me. So now we have half of our annealing plate, correct? So we want to actually mirror this piece now, and we're going to use this as our mirroring line. So I'm going to select all of this, select this, select this, select this, and this. And I want to, now I've got everything I want mirrored, and I'm going to say mirror this against this line here. And look at that. Wow. Amazing. I love that feature. So now I've got my halves put together. I'm going to trim out my center lines. And also now you can see we've got segmented lines here. If somebody knows how to intersect these two lines, I'm sure there's a way. I'm not going to figure it out right now. Let me just see if I can go like this and right click, fix, unfix, perpendicular, equal, midpoint. I don't know. There's got to be a way to line those two things up better than what I'm doing. With trimming them out and then just recreating the line. I'm sure there's a feature that I'm unaware of. So if you know about that, leave me a comment down below and help me out. So, all right, now we have our annealing chamber, right? I'm sorry, we have an annealing plate. We have one version of this. I'm going to go ahead and say finish sketch, and it'll now we have our piece here. You can see it's just a flat drawing of what we have inside of Fusion. It's in our sketches up here, and for due diligence, I'm going to name this Annealing Plate. This is something to keep you organized. Remember, I talked about this on the beginning of the video, is that the annealing plate itself is it's really just going to be labeled sketch 1 if you don't label them. So if you just double click over here, you can modify your sketch names and your body names. Speaking of bodies, let's make this a body. So now we want this to be a solid piece inside of Fusion. I'm going to right click on it, hit extrude, and it's going to ask me, Brian, how thick? What kind of plate steel are you using? I'm going to say, well, I'm using 1/8 inch. So let's go 0.125, and it's going to create a 3D version of that plate. And now we have that in our system. And if you look up here, we have bodies now. So we're going to go down and we have body 1, which is this piece. And we're going to rename it to Annealing Plate number 1. So we're staying organized over on the upper left-hand corner there. And we're going to go to the top. Now, because this annealing plate, there's going to be multiples of them that, remember, we're building a shelving system inside of our forge. This annealing plate, it will be duplicated multiple times, but it's going to be duplicated on risers that are going to fit. That 0.25 rod is going to fit right inside of these holes. So let's go back into sketches. We're going to go create sketch. It's going to ask us, hey, what plane do you want to draw this on? And again, we're going to use that top plane. So we're going to click that, and then we're going to turn back on the sketch for the annealing plate, because we're just going to go ahead and draw it right on the inside center of this piece here and use it as a reference. We're going to click circle or hit the C key. And because that rod is 0.25, this makes it pretty simple. And get rid of the dimension there, and we're going to go ahead and finish the sketch. That's literally as simple as it is. And now we've got, we could potentially create one sketch that references all 6 of these. So let's go here, change the name to risers, and then right click and hit edit sketch. Go back into here. Oh, and you can see here too, my segments, my hole here is segmented for the center hole. That's not a big deal. We'll leave that. Change that for later. And I'm going to make risers for each one of these. 0.25. And now we've got 6 different risers here mapped out in the locations where I want them. I'm going to go ahead and I'm going to select them all, and I'm going to hit right click on it and hit extrude. And we know that we want 4 inches approximately, about maybe 3.5 inches, 4 inches. Let's just say 4 inches. We can always trim them down later. So we're going to hit 4 inches on those and hit OK. And what it's done is it's created bodies for each one of these. And let's turn on our annealing plate so we can get a 3D view of this. Ooh, yes, very fancy, very fancy. So now you can see where I'm going with this. We have 4-inch risers coming off of the base of this annealing chamber plate, and all 6 of those risers are created. So now, obviously, we want to duplicate this annealing plate because we're going to need multiple shelves on the inside. So let's go to the annealing plate itself. We're going to hit Control-C and then Control-V, which will give us the this nice little fancy menu here, this little arrow menu here. And if you grab either one of these arrows, it will allow you to move it only on that one axis. These little squares, it's kind of like a freeform move, so you can freeform and move them wherever you want. In this case, we really only want to move it on one axis, and that's the vertical axis. So we're just going to bring it up about probably about a 1/2 inch. But in order to understand, how many we can get in there, we're going to give ourselves a better view, and then grab this arrow and go up. Let's go up a 1/2 inch, and then if we hit enter, it's going to set that movement. Okay, so now you can see we've got our shelving system, and at this point it's just wash, rinse, and repeat. So let's stay organized. We can keep our annealing plates together. I'm going to copy both of them. Why not? Just takes the work out of it. And raise those up 1 inch. And keep ourselves organized up here. And in this case, I think I'm just going to go ahead and do another set of plates. Okay. And how many do we have here? 1, 2, 3, 4, 5, 6. It's nice. Gives us a lot of room in there. Let's do another set. So we'll have 8 total. Very nice. I like that. It's a very, there's a lot of thermal mass here. That's what I really like about this, is that there's a lot of steel in there to warm up and to give us nice, even heat on our blades. Remember, that's the whole purpose of this. And some people may ask me why I need to anneal my steel, because I do stock removal on my blades. A lot of times the steel comes in already annealed. Well, I do cut my blade blanks out on my Crossfire Pro, which is a plasma table, and it will, there's something called the HAZ, the heat affected zone. So high carbon steel, once you heat it up and it cools, especially since there's water in the table, it can harden. So I need to throw it in my forge after I've cut it out on the table, and to allow it to actually anneal properly, so I can work with it and shape it and not worry about cracking it. All right, so I'm happy with that. I'm going to go ahead and hit save on this, and we're going to title this Annealing Plate and put it in, we're going to go ahead and put it in our knives folder and say okay. That way we, if something were to happen, our machine were shut down, we'd have our files and folders all backed up. All right, so now that we've got this, I want to actually try putting in one of the biggest blades that I make, and that's in this case this is going to be the I'm working on a Japanese cleaver called a Tinker Tank, and I have it drawn up already. So I'm going to go ahead and hit insert derive, and it's going to ask me like, hey, you know, what do you want to input into this? And I'm going to say Tinker Tank, hit select. I'm going to highlight the whole thing and say OK, and it's going to slide it in for me, and you can see here it is, but I need to position it. So over on the left-hand side, go to my top view, and I'm going to select Tinker Tank over here, and I'm going to hit M for move, and it's going to allow me to, remember I talked about the freeform movement. I can do that with this, and wow, look at that. It fits. All right. That's awesome. So now we know that we could slide this in right there. And let's get a different view here of this thing. We can see where it is on the planes. And we now know that, yep, look at that. We have plenty of room inside the chambers, each one of the chambers, for it to slide in there. And I could fit 1, 2, 3, 4, 5, 6, 7 in there total. So that's quite a few. I don't know if I'll ever make that many at once, but I do like the concept that I'll have plenty of room for at least 7 blades, and if they're shorter blades, I could potentially slide them in on this side too, right? I mean, we could do a whole bunch of stuff inside of this annealing chamber. All right, so now that we have our design done, we know that it's good. I'm gonna go ahead and save it. I know what I need to cut out on the Crossfire table. So the next step is to, I'm going to disable the bodies. We don't need that anymore. We're going to go back into sketches, and we're going to look at the annealing plate. And I know that I need to cut this out on my table. So I need a Dxf file in order to do that. And Fusion makes this really simple. Now there's functionality inside of Fusion that will allow you to create G-code for your plasma table. In my opinion, I'm not a big fan of that. I don't like how it nests and how it actually creates the code. It was not very user friendly in my opinion. So I actually use a piece of software called SheetCam. And SheetCam, all it does is it requires me to have a Dxf file. So one thing I didn't do is I didn't fix my my circles here. So let's go ahead and hit. I'm gonna just go ahead and delete this one, and real quick, I'm going to draw a circle. You know what? I'm gonna use the old circle as a point of reference because Let's see. Oh, I wasn't in Sketch. That's right. I wasn't editing the sketch. That's the reason why it wouldn't work. So let's try this here. Oh, it will work. All right, so let's go ahead and delete it. Center off of that, 0.30. We're going to do the same thing down here. And right between those, I think I'm dead on right there. All right. So now we got we removed our line segments. All right, so I'm going to go ahead and say finish sketch. Got that cleaned up. Let's go ahead and just create a Dxf file. Now, a couple of things you really want to pay attention to in this is that your document settings up here, you want to make sure that you're working in your proper units. All right, if you're using inches, make sure it's set to inches. If you're using millimeters or the metric system, you're going to want to select millimeters. In my case, I'm on the imperial system, so I'm going to use inches. And go ahead and get into the annealing plate here. Right-click it, and it's as simple as this. Save as DXF. And then I use Dropbox for this because the machine connected to my plasma table is a different machine that I design on, so I want it to sync up. I have a folder specifically for this called SheetCam, and we'll go ahead and call this the Annealing Plate Final, and hit save. And that will now be in there, and we can go over to SheetCam and import this into our Langmuir Systems Crossfire Pro. So let's go ahead and open SheetCam. As you can see here, this is our what we call the job option. Inside of job options here, you can actually tell it, hey, I'm working with a 24-inch by 24-inch piece of plate steel, which is correct. You can actually tell it the thickness of the steel. And that will give you kind of a layout as to, since we're cutting multiple pieces, we'd like to know, like, hey, how can we lay these things out on this piece of steel? So I'm going to hit OK on that. And the first thing you're going to want to do is you're going to want to import your part. So over here on the left, you're going to see a little thing called parts. You can right-click, hit New Part, and then say yes to this. And we're going to go find our Annealing Plate Final file. And we're going to open that up and import it in. It's going to say, hey, where do you want to put it? And what kind of scaling do you want to use? Obviously, I'm in the imperial system. I'm going to use inches. And on the bottom left corner to import it, that's totally fine. And there we go. And you can see here that it put it in the lower left-hand corner. And you can see all the different contours and all the different holes that are inside of this thing. Now, the way that the table works is it needs to understand each one of these paths. And it needs to know, like, hey, how do you want to cut this? And that's why I love SheetCam. That's the beauty of SheetCam, because I can individually layer each one of these. I can give different feed rates. I can give different interior and exterior contours, pierce points, pierce delays. I can do all of that. It's all customizable. But in this case, we just need two different layers. We're going to do an inside and we're going to do an outside layer. And we also need to tell it to cut the inside first, right? Because you're cutting plate steel, and if it goes around and cuts this outside piece first, now you just got a piece of plate steel floating around in here that's kind of small. You want the weight of the entire piece. You just want those interior cuts cut first. So let's go to the contour tool, and that's up here, or you can click this, and we're going to select all of our interior contours. And if you just click and drag, you can actually get all of them at the same time. And then you're going to right click on it and you're going to say move to layer. Now in this case, we need a new interior layer. We're going to say new layer, label it inside. And so now it's differentiated between these are different layer on a different layer than the outside cut. Now you can see up here in the upper left hand corner, we have 0 and inside. I'm going to rename 0 to outside just so we can stay organized. And I need to tell the machine, okay, I want all of these cut at a specific feed rate, and also I want my start points at a specific way. So we need to create an operation. So in the bottom left-hand corner, we're going to right-click, hit Plasma Cut, because that's what we're doing. We're plasma cutting today. And it's going to say, all right, what contour method do you want to use? All right, I want to use the inside offset because it's cutting on an inside. The layer itself is inside. It's already selected. I could select either one. It's going to ask me what tool I'm going to use, and since I only have one tool for this, it's already set up in my system. And then the feed rate, 60 inches per minute, looks good to me. And then down here, this is kind of important. I never do a lead out, but I am going to do a lead in on this case. And because we're cutting 0.30 holes and slots, I'm going to do about a 0.2 inch lead in for each one, and I'm going to do perpendicular. And the reason for that is through experience I've learned that if I use arcs or tangents, sometimes I get damaged, especially with small holes like this. I can get damaged outer lines, so I don't want that. So all that looks good. I'm going to say okay to that, and you can see now I've got my first tool path already imported here into SheetCam. The blue line is the path of the tool. The green line is where it's going to cut. And because I'm a little OCD, I like everything to kind of match up. I'm going to go ahead and hit my, this is the start point tool. I'm going to click where I want my start points to be and my slots. I want them all kind of in the same way there, so everything's cut in the same. And then that looks good for the interior cuts. It's a good tool path to go by. Now, just to finish this plate, we need to obviously cut the outside contour. We are going to do the exact same thing. Right-click on Operations and hit Plasma Cut. Then we're going to go up to Outside Offset because it is cutting on the outside of this line. Same tool, but we need to change the layer to Outside. Remember, we've got our layers up here in the upper left-hand corner, outside and inside. 60 inches per minute is fine. Perpendicular in this case, because it's an exterior contour, I'm going to say arc, and I'm going to give it a 0.3 lead in, because if there is a little bit of damage to the outside, I can hit it with a grinder and polish that edge. So I'm going to say okay. And it kind of picks for me where it wants to put that start point. You can see now it's arcing in over here. And I'm going to change that to, I'm going to come down here, select this, and select my start point. I'm going to tell it to arc in the corner right there. So, all right. So now we've got our operation set up here. I feel pretty good about this. I'm going to move the entire piece in on the plate just slightly so I can set my X and Y axes at the bottom left-hand corner of the plate and still have a little bit of spare around the outside edge there. That's just something I've done over time, and it seems to work good. But now I need 8 of these plates, right? So I want to cut all 8 of these at the same time on the same piece of plate steel, and I don't want to have to, set my machine up every time. I just want to tell it to cut all 8. And SheetCam makes this super simple. So I'm going to right-click on the piece, and I'm going to say Array Parts. Okay. You can do multiple duplicate, and that's fine too. And you can, by hand, you can lay these all out. But array parts will actually ask you how many numbers of columns, how many numbers of rows, how far apart you want the pieces, and all of that. So columns, I know that I want 2 columns of this, and I need 8. So I'm going to do 4 rows of each. And in this case, I'm going to do 0.2 inches between each on the X and Y axes. That gives me just enough space between each one. And hopefully this will lay out just fine on this sheet if I did my math right. All right, yeah. Look at that. That looks great. Now we can lay all of these out on one piece of plate steel and not worry about the piece going over the edge or hanging over or anything like that. So it looks good. And in fact, we could probably go, put a little bit more space between here and tell it to cut this out, give it a little bit more space. So let's go into Array Parts and change this to 0.5. And okay. Oop. I don't want to rearray. Let's get rid of that. Go into Array Parts, change this up. This looks right. Okay, 0.5. There we go. And then we are going to select them all, move them sort of into the center of the sheet. And yeah, looks good. Maybe move it down to the bottom. We have a little bit left over up top here for something else. All right, and the final piece to this puzzle is to actually run the post processor. There's a little P in the upper left-hand corner here. We're going to hit that, and it's going to create our tap file in G-code, and we're going to hit save. Now we are ready to send this file to the Crossfire Pro. Let's move over to the table and get this thing cut out.
All right, so now we're in the fire control software. We're going to go ahead and import our Annealing Plate.tap file. Here it is right here. And say open. And voila, there it is, all 8 of them. And I just need to now put the piece of steel on the table and get that all centered up, and then we're gonna put our X and Y axes. We're gonna start at the bottom lower left-hand corner of the piece of steel. Take our piece of plate steel here, down on the table, and I'm gonna grind a small spot where I can put my ground. I like to do this because sometimes if you don't have a good ground on your table, you'll lose your cut halfway through. So we don't want that. Now I've got my ground strap kind of rigged up here. I got all my slats in the back here that are grounded, and then I have a nice magnet here so I can magnetize the piece, the ground strap, right to the piece. Let's get everything lined up to X and Y axes, and let's start cutting. All right, we're all set up and ready to cut. I'm going to go ahead and put my respirator on and my head, my ear protection, and we're going to turn on the plasma cutter and get this thing cut. All right, so I got 7 of them cut out. I did have a couple that sort of, the Langmuir systems, the razor weld sometimes doesn't fire, and I don't really know why. I know there's an update that they put out that they said it would fix it. But the parts came out really nice. They look good. Very little dross. There's just a little bit on the back end, and nothing that can't be cleaned up using a grinder. So it came out okay, and as you can see, this is the bottom piece of the steel plate. I have very little waste. All right, now I just need to cut some 4-inch pieces of this 1/4 inch round. Yeah, everything lines up pretty good. Just gonna take these rods over and clean them up on the Revolution. All right, as you can see, we're all set up to actually put this thing together now and fabricate it. The plates came out pretty great. I've got 7 of them off of the Langmuir Systems Crossfire Pro. I've also cut some 4-inch, 1/4 inch round, some pieces here, and I rounded over the edges. Essentially what I'm going to do with this setup is I'm going to use a magnet and just kind of line everything all up with a square here. And we're going to TIG weld this today. I'm not a big fan of TIG because I'm no good at it. I do like using it. It's just I'm terrible at it. My go-to is MIG because it's easy. I can make it work. It looks good and all that. But this is a perfect perfect test for me to kind of run with my TIG welding skills, because it doesn't really matter what this looks like. This isn't a beauty project. And also, I have been inspired by Jeremy over at Simple Little Life. He has been practicing his TIG welding on his, he's got 2 channels. Jeremy Gertz is the other one. I'll put links down in the description so you can find it. But then, of course, Simple Little Life, where he makes his knives and everything. You know, I watch him kind of sort of you know, take steps and learn, and then also film himself learning doing it. So it's you know, there's a lot going on there that I really it helps me and inspires me. So I appreciate you, Jeremy. Thank you so much. But today I'm gonna do the same thing. I'm gonna get out my Prime Weld TIG welder. Big shout out to Prime Weld. About a month ago, my Prime Weld TIG popped. I don't know what happened, but I called their tech support and their customer service was awesome. These machines have a 3-year warranty on them, so the guys basically told me to toss it and they would ship me a new one. I actually had one the next day. They FedExed it to me at no cost to me. So big shout out to Prime Weld. I will put links down in the description because I got that on Amazon, so you can find one for yourself. But anyhow, let's get this thing going. I'm running straight argon today through the TIG, and probably going to run around 100 amps, I would say. And hopefully these will look better as we climb the ladder. Every one I do, I hope will look a little bit better, but let's get it going. You can see on this one here, my amps were a little too high. I went to about 120 on that one. And then this one, it was about right. This is 110 amps. So not getting a ton of warping or anything. Nothing I can't fix anyhow. So I think I'm pretty happy with that. Not going to really try any filler rod. I'm just going to do tacks for now, since this doesn't have to look too pretty. But let's keep going. Well, one thing is for sure, that I am terrible at TIG welding. I have learned quite a bit about controlling the puddle, a little bit about the amperage. This turned out to be about 115 amps, give or take. I've blown away some of the steel here. You know, did a few terrible welds, but the welds did get better over time. So I will say that this is a success, and it feels really nice and heavy and solid and everything. So I do think that this is okay. However, probably the next one I'll build won't be with TIG. It'll probably be with MIG. It'll make a little bit more sense for me as far as the time goes. I do want to get better at TIG, and I will focus on that a little bit more. But anyway, so at this point, I really need to just see if this will fit in the forge, and I've got it right here, so I might as well give it a shot. I went with 2 plates on the top that were kind of close together. It turns out I really only could fit 7 in here anyway, with as many as I could on the risers, and I figured more on the top would be better. So let's give this a shot. Yeah. And again, I don't know how long this thing's going to last. I mean, it is mild steel after all, so it could break down pretty quickly over time. It'll be kind of interesting to see how the way that the flames come down over the steel, because there really isn't a ton of room at the top there. We may end up having to cut this thing in half. I just really don't know. This is part of the prototyping process. So, yeah, I'm excited to see how it fires. let's give it a shot.
So my concern really is the distance between that flame that's coming out of these burners and the top of that steel. So I don't know if that's going to work out or not.
Looks like it's firing pretty good. Go ahead and close up this back door. Looks like a test fire is pretty successful. I think at this point, we know it will fire, and I should take it outside and do the real thing. All right, let's get this forge fired up. All right, I've got the forge all tuned up and ready to go. A little bit warm on the inside. Let's go ahead and throw the annealing chamber in. All right, I'm going to time it and see how long it takes for everything to get cherry red hot on the inside. Three minutes in right there. Looking pretty good. Red hot in there. All right, I'm going to put knife blank in there, and I've also got a platen here that I need to heat treat. All right, well, it's the next day, and this has been left overnight to cool, and just take this thing out of here and see how well it fared. Let's see where the two burners hit the top of it, and I would imagine over time this is where it's going to be deteriorating the most. Overall, the welds look like they held, which is pretty good. So it's good. But yeah, lots of decarb there. The knife itself looks good. Looks annealed to me, but I'm going to grab a file and just check to see if that's the case. Now, if this is still hard, I won't be able to really dig in too much to these edges here. Yeah, it definitely looks soft to me. So the annealing process did work. So as you can see, this is a success. Now, is it perfect? No. In fact, there's some pretty major changes that I'm going to actually deploy on the second round of this prototype build. One of which is I'm going to lower the height of the thing and turn it more into a doghouse style, where there'll be a peak and then the flames will cascade down the side, and it will create a little bit more space for the burners to actually push down the heat. Also, a couple of things that I've learned after using this thing for a couple of weeks. I've done about 4 annealing treatments in it and 2 failed heat treatments. And the reason why the heat treatments failed was because I left the blade. I was silly enough to think that I could leave the blades in there and then quench them and then do multiple blades at once. And the reality of this is if you leave the high carbon steel in there, or even stainless, you could burn out the carbon, and which I actually did that on a couple of blades. So the reality is by lowering the top and only allowing for, say, 3 spaces for blades. I think 3 is probably a decent amount to keep straight in your head, so you don't run out of time in between quenching and so on. Then it kind of kills 2 birds with 1 stone, right? It's a lower height, so the burners have more chance to cascade the heat down the sides, and then also you don't have room for 6 blades when you run out of time, to get them out. You meet critical temperature, and once that happens, you only have a very small window of time to actually quench the blades. But for annealing, this thing is amazing. In fact, it fits in my kiln. So my kiln, which is what I have upstairs to my electric kiln, I put blades in it also and let them get to temperature, and that works really well for annealing. Also, in the forge, it works insanely well for annealing because I can slide 6 blades in there and come back the next day and they're all annealed and they're perfect. So I'm super happy with it. The key to this is, though, when you're annealing, is that you'll want to put the blades in there after this is heated up. You don't want to throw this device in there with the blades in it and then warm it up slowly. You're going to want to put this in there, fire it up, let this get to non-magnetic, slide your blades in, let them get to non-magnetic, which will happen really quick, and then close it all up and leave it overnight. When you do that, you will have perfectly annealed high carbon steel that you can work with, you can shape it, and then you can do your thing and create a knife with it. So I call that a success. I learned a lot in the process. I hope you did too. It was really fun to kind of put this video together. I know it's a long one, and I appreciate you following all the way through if you did. And you kind of saw my process and how I put things together, prototype them, and then try them. Very rarely whenever I do this is the first time around does it work out the way I wanted it to. Would this function as an annealing chamber? Yes, it would. But is it perfect as an annealing chamber? No, it needs some small improvement to make that happen. Most likely, moving forward, I will always use my kiln to heat treat my blades. I just cannot get a consistent, now that I have a Rockwell hardness tester, I cannot get a consistent heat treatment out of my forge without a thermocouple and going down that road. It just seems like a little bass-ackwards when I have an electric kiln with a PID and a thermocouple that'll tell me the exact temperature and all of that jazz. So I think I'm just going to keep heat treating with my kiln and use my forge for forging, obviously, and annealing. So anyhow, guys, if you got something out of today's video, make sure you hit that thumbs up button. And if you're not already subscribed, hit that subscribe button. And if you click that little bell, you get a notification every time I upload something to YouTube. Now, there's many ways to support my channel. Patreon is a great way. Buy me a coffee is a great way. Go to my website, housemade.us. And if you're interested in the Revolution 2x72 belt grinder project, we're always releasing new things for that, updating the plans and so on. So you can go to housemade.us and do that. I would greatly appreciate it. So anyways, guys, thanks for hanging out in my workshop in my studio. Until the next time, keep on grinding. My name is Brian House, and this has been Housework.